Curve defined by parametric equations. Before introducing parametric equation, I would like to go over a rectangular equation first. Rectangular equation, what is a rectangular equation? We have been using that a lot. Y equals to x, y equals to x squared, y equals to x to the third, which is y equals to some x. So a dependent variable equals to some numbers and independent variable. So let me do the writing. Rectangular equation. Let me use y equals to -1/72 x squared and then plus x. And then this one, I would like the domain be from 0 to 72. Then what is the graph look like? First of all, this is called a leading coefficient because this term has the highest power, second power. So the entire term is called a leading term, and then the number in front of x is called a leading coefficient. Since -1/72 is less than 0, so second degree means a parabola either opens up or opens down. For less than 0, we say the parabola opens downward. And then when x is equals to 0, what is y equals to? Y equals to 0. That is easy, right? When x is equals to 72, y is equals to -72 plus 72, that is equals to 0. And then we do a graph. So that is my y-axis, and then that is my x-axis, x, and then a y. We have 0, 0. We have 72, 0. And then this parabola is facing downward, and that looks like this, from 0 to 72. And then what else do you see? I should say what else you don't see. When you draw a curve, you go like this, right? Or you go from right to left. When you draw a graph, let's say y equals to x to the third, you go like this, right? Have you ever go from bottom to top? That is the matter of direction. Should I always go from left to right, right to left, top to bottom, or bottom to top? That is the direction. Which way should we go first, left to right or right to left? Okay, so I will say this curve does not show any orientation. Show any orientation or direction. What is orientation? The orientation is another word for direction. So the orientation refers to left to right or right to left. Left to right or right to left. And then this word orientation is what we need in parametric equation. So to find orientation, we don't have it. Let's find it. To find orientation, I need to introduce a third variable. That will be a t. It's a third variable. And then t has a name. T is called a parameter. That's why the equation is called a parametric equation. Parameter. And then we write x and y in terms of t. X and y in terms of t. In terms of t. Okay, how do we do it at this time? I will just give you the parametric equation. Don't worry about the step at this time. So let's put a note in here, because you may pause my video, just do some writing. I'm going to put a note so that won't confuse you. Hey, where do you get this parametric equation? At this time, I will just give you the parametric equation. Okay, I pulled something out from my pocket, give that to you. Hey, it is what it is. Let's use it. Note, don't worry about the steps. At this time. Okay, don't worry about the step at this time, and then let me give you a set of parametric equation. X is in terms of t now, 24 root 2 times t, and then y is equals to negative 16t squared plus 24 root 2 times t. X is in terms of t, y is in terms of t. Let's do some name. This is a parametric equation for x. And then the other one is parametric equation for y. One for x, one for y. X and y are in terms of t. And then how do we get the graph? We will just do the most basic method using some table values. So let's draw a table. So I have a t, and then we select some values for t, right? So are there any restriction? Let's say t greater than 1 or t less than 0? No. T, you can just multiply a number, a square, a t, so there is no restriction. I will just pick positive. So let's say 0, 1, and 2. And then we plug that into x, which is 24 times root 2 times 0. And then 24 root 2 times 1, 24 root 2 times 2. And then the y is negative 16, 0 squared, plus 24 times root 2 times 0. Negative 16, 1 squared, plus 24 root 2 times 1. Negative 16 times 1 squared, plus 24 root 2 times 2. Oh, times 2, 0, 1, and 2. Okay. And then I will obtain a point, x comma y, and order pair a point. This is 0, comma 0. This one just approximate. That is a 33.9, comma 17.9. Using one decimal place is enough. This is a 67.9, and then comma 3.9. So my graph was looking like this. Okay, my graph was looking like this. It's a half, it's like a semicircle or upside down parabola. And then when you draw this graph, I will do y-axis and then x-axis. So this is x, and then this is a y, and then I have a 0, 0. And then, oh, you know what? I would just copy and paste the same graph first, because the parametric and the rectangular, they are the same graph. This is a 0. This is a 72. And then 0, 0 is right here. 33 and then 67. I will say this is a 33 and then this is a 67. And then do we agree that we got this point first and then next, right? So that gives me an orientation. So we go this way, and then this way. So the orientation is just like the direction. And then what is this called? This one has two names. Depending on the books you use, we call this a parametric curve. Or we can use a big C to represent that, or you can call this a plane curve. Also use a big C, parametric curve, plane curve, parametric equation, parametric curve. The names is consistent. Okay, so since we have parametric curve, a plane curve, then let me give you a formal definition, and then we will just end this video, and then I will introduce something else in the next video. So let's do a definition of a parametric curve. So definition of a parametric curve, plane curve, parametric plane curve. And then if f and g are continuous functions of t on an open interval I, then the equations x is in terms of t, x is f of t, and y is in terms of t, y we call that g of t, are parametric equations. If I am doing this writing too fast, you can pause this video at any time to catch up on the writing. Okay, so we have x is in t, y is in terms of t, and then these are parametric equations. Let's do some highlight as well. And then also, and t is the parameter. Right, we have a new vocabulary. T is a parameter. So I will just highlight T and then parameter. All right. Okay, how about the points? Okay, next step, let's do the point. The set of points, x comma y. The set of points, x, y, obtained as t varies over the interval I is the graph of the parametric equation. And then we take everything together. So taken together. The parametric equations and the graph are a plane curve. This plane curve, another name parametric curve, denoted by C. Cap big C. Okay, let's do some highlight. Plane curve, parametric curve. Okay, plane curve, parametric curve is denoted by C. Okay, so let's do a short summary. So what do we have to do? We have a parametric. We have a set of parametric equation, and then I will select values of t in increasing order. This t must be in increasing order. So I go from 0, 1, 2, not 2, 1, 0. And that is that because we need that to see the orientation. And then we plug in t to obtain the points x comma y, and then we plot them. Plot all the points and trace the direction or orientation direction. And then this direction is also known as the orientation of the parametric curve. All right, so that is a quick introduction of rectangular equation, parametric equation, and how to sketch the graph of a parametric equation and its formal definition. All right, so to do more related to parametric and rectangular, I will do that in the next video.